Hi everyone! Today we'll solve this circuit using the node voltage method. By applying Kirchhoff's current law, we'll calculate the current flowing through the 3-ohm resistor. Let's get started. Let's begin by identifying the essential nodes in this circuit. We name them as VA and VB respectively. These node voltages will help us apply Kirchhoff's current law and solve the problem step by step. Now, let's assign branch currents to every branch of the circuit. We'll assume the current directions first, they are just reference directions. Notice that the current value comes out negative, it simply means the actual current flows in the opposite direction. Now we're ready to apply Kirchhoff's current law. Now let's apply Kirchhoff's current law at node V. According to KCL, the current entering a node equals the I1 leaving it, so we write I1, I2 plus I3. Let each current unit simplify the equation, 5n our first node equation. Now let's apply Kirchhoff's current law at node VB. At this node the current I3 enters while I4 and I5 leave. Therefore we write I3's current using Ohm's law. Simplifying the equation gives us our second node equation, Va minus 7V minus 18. Great! Now we have two simultaneous equations. We'll solve them together to find the unknown node voltages. After solving, we obtain V of 4.6 volts and V 3.22 volts. These node voltages are the key to calculating the required current through the 3-ohm, the final step. Now it's time to calculate the current through the 3-ohm resistor. Using Ohm's law, the current I3 is equal to voltage difference across the resistor divided by 2 volts. We get 5 watt with 2.444 amperes. Excellent! We've successfully solved the problem using the node voltage method. The current through 3-ohm resistor 0.444 amperes flowing in the assumed direction. Remember, insulated value had been negative. Keep practicing node voltage analysis to master circuit solving. Let's quickly recap the node voltage method using KCL. First, identify your nodes, then mark all currents. Apply KCL at each node, solve for the voltages. Finally, calculate the currents. And that's the recap.
The adventure isn't over yet. Subscribe to MindSpark Tunes for more amazing stories, history, and learning adventures. See you next time.